Hi everyone, I'm John Kay, a program manager on the Windows Location Platform team, and today I'm going to be talking to you about using the Geolocation and Geofencing APIs in your Windows Store apps. I appreciate you joining me today. We're going to be covering the APIs, the new Geofencing background task type. I'm going to be walking through some code, and I'm going to be showing some of these APIs tied together in a demo location-based reminders app. Integrating location-based scenarios into your app is easy. Whether you need location for simple scenarios or complex scenarios, our intuitive API set is simple to understand and ready for you to start using right away in your Windows Store apps. These are all Windows Runtime APIs, meaning you can use them fully from your language of choice, whether that's C++, C#, or JavaScript. First, let us briefly cover the geolocation APIs. The Geolocation Runtime API set was introduced in Windows 8, and in Windows 8.1 we've added even more functionality for you to enhance your apps. All of these can be found in the windows.devices.geolocation namespace. We introduced some new shape objects for points and circles. We added some new properties that were introduced in Windows Phone 8, which allow you to make smarter decisions when requesting location data and when dealing with the results. Having parity with these APIs allows you to share code easier between your Windows and Windows Phone apps. GeoPoint and GeoCircle are both geoshapes. A geoshape is lightweight and simply consists of the shape type and then the spatial reference ID and the altitude reference system. Spatial reference ID corresponds to the spatial reference system based on the specific ellipsoid used for either flat Earth mapping or round Earth mapping. The altitude reference system allows you to choose different reference points such as ground level, surface level, sea level, etc. And geopoints can be thought of as exactly that, a geographical point containing a latitude, longitude, and altitude. Note that geocoordinate latitude, longitude, and altitude have been deprecated in favor of using these new properties on GeoPoint. So geocoordinate has a point property which contains these new properties. And lastly, we have GeoCircle, which consists of a center, which is a latitude and longitude, and a radius. GeoCircles can be used to create geofences, which we're going to be explaining in a bit. Now, as it's expected that most apps really don't care about spatial reference ID or altitude reference system that much and will prefer to just use the defaults, there are various constructors to make it easy to create geopoints and geocircles with varying amounts of customization. Now you can set a particular desired accuracy in meters using this new property. It's getSet, and this tells the system what accuracy of detail you want your location results returned in. And this maps to the existing property of position accuracy, which was available also in Windows 8. Asking for an accuracy less than 100 meters in detail results in the high accuracy choice. Now, high accuracy means that the system will always attempt to use GPS if present, as opposed to default, where the system will only use GPS if it needs to. For example, if Wi-Fi cannot be used to get location. Now, if you want to know where the location results came from, you can use the new position source property. It's get only, and it lets you know if the data came from cellular, satellite, Wi-Fi, IP address, or an unknown source. However, as all of the location sources have a full spectrum of accuracy, it's recommended to vary your UI based on accuracy as opposed to just varying it based on the position source. And lastly, there are 3 read-only properties for detailed satellite information for the satellites used to obtain location results. If precise GPS satellite info is needed for your app, then you can use these. They help determine the accuracy of position results. So here is some pseudocode of some of these tied together. This is just a very basic example. Imagine I wanted to create an app to get location via GPS and then display some of these new precision properties. So I simply create a geolocator object, then I set the desired accuracy in meters to 50. Now I'm going to go ahead and get geoposition async, which is actually getting the location. And now once I have the location results, I'm going to check the position source. Now, if the position source is satellite, meaning GPS, I'm going to go ahead and display these new precision properties. But if not, then I'm just going to display a message. All right, so now let's move on to geofencing. Geofencing can be thought of as a virtual perimeter around a real-world geographical location, used to trigger the app to do some action when a user enters a geofence or leaves a geofence. Maybe the area is something small, like my condo or a local coffee shop, or maybe it's big, like the city of Redmond or the state of Washington. Am I in it or am I outside of it? In Windows 8.1, you can define geofences and the associated conditions to make the geofence trigger. The system monitors all of the geofences for your app and tells you when one of your geofences is triggered. You can even enable this to function for your app when your app's in the background or the system's in connected standby. And now by us tracking geofences on your behalf, you don't need to worry about tracking location, and any optimizations that we make to either battery usage or resource usage will benefit all apps that use geofencing. Now, geofencing can be used in many exciting ways, and here's just a small handful of the many things you can do with it. So one example is location-based reminders, which I'm going to be showing you here shortly. Imagine you have an app that reminds you to pick up a jacket from your friend's house or to get milk at the grocery store, but it reminds you when you're actually there and when it's relevant. Or other contextual information at an area of interest, such as reminding you to use your loyalty card at a store or offering you a coupon at the coffee shop when you're waiting in line in the morning to get your coffee. Or alerts. Imagine a bus app waking you up before you get to your bus stop. Or an app that tells your family that you're on your way home from work once you leave work. There's also automatic action, such as an app that likes to perform check-in or check-out for a user. An app can use geofencing to automatically check in the user and then check them out when they leave the location. And lastly, imagine you're on a trip and you have your windows slate, and as you're walking around looking at landmarks, as you get close, all of a sudden your app tells you, hey, here's some information, here's some tour times, and here's the cost. And this is just a few of the examples, and we know that you are a lot more creative than us and will come up with some really cool apps. As mentioned, geofences can be of varying sizes depending on the scenario. For example, for the location-based reminders app, I have different reminders set up for these small little coffee shops that you see on the map, and these are the red circles. And it's just a reminder to myself to skip getting the sweet drink because I need a constant reminder to eat healthy. And next I have, the green notification, and that's a geofence around the Redmond Town Center. That's a notification to remind me to buy something at the store. And then I have an even larger one around the greater area of Redmond, and that's just reminding me to text or call my friend who I haven't seen in a while once I get into the city. So at a high level, it's as simple as you creating fences from your app and then telling the system to monitor them. If your app's in the foreground, meaning the user's looking at it, fence notifications go right back to you. Now, if your app is suspended and in the background or the system's in connected standby and you're set up for that, when the geofence is triggered, we utilize the background task infrastructure to get notifications back to your app. Either way, the fences are for your app only. No other app can see them or get notified when a user goes into or out of your fences. Geofences have a few simple properties which allow you a wide range of customization for your particular app. Now, only the first two properties are required, and the rest are optional and have defaults if they're not declared. So you have the ID of the fence and the geoshape of the fence. The ID is a string, and the shape is a geocircle, which I described earlier, consisting of a basic geoposition and a radius, the basic geoposition being the latitude and longitude. Geofencing only supports circles at this time. Now, do you care to be notified when a user enters an area, leaves an area, or both? That's where monitored states comes into play. You'll also notice that there's a value for removed, and I'll touch on that in a few. So next, there is single use. Do you want to be notified every time a user enters or exits a fence, or only once? If the fence is set to single use, after it's been triggered, it will be automatically removed by the system. And so that's where the removed monitored state comes in. If you have registered for it, you would be notified when that fence was removed. Now, dwell time is the amount of time that a user must be inside of or outside of a geofence before it triggers. Imagine you want a user to be inside of a store for 2 minutes before you offer them a coupon, as opposed to offering it to them right away when they get in range, because they might have just been walking by the store and not even coming in. Start time allows you to create fences that start at a future time, and duration allows you to specify when a fence should expire and be automatically removed by the system. Now, if you've set up for the removed monitored state, When a fence expires and is removed, you would also be notified in that case. So given that there are so many properties, and you might not care about all of them, we've made it easy to create geofences by providing multiple constructors. You can specify just the pieces that you care about and utilize the defaults for the rest of them. Now, once you create geofences, you need to add them to the Geofence Monitor to monitor for you. Now, there's various properties, events, and methods on Geofence Monitor. The monitor itself has status to let you know if it's still getting location data from the system, and you can actually listen to the status changed event if that's important to your app. Now, when a geofence is triggered, the geofence state changed event will signal you to take action. At this point, you can read reports, which will let you know which geofence triggered and all the information about the triggering, such as the accuracy, the timestamp, the location. However, at any point, you can also just query for the list of fences or the last known geoposition. All right, so that was a whirlwind of API information. So let's see a geofencing app in action. So we have created a basic location-based reminders app using the new APIs and using the Bing Maps SDK. So let's go ahead and just build this from Visual Studio. Now, I've already launched this app, but if I hadn't, the first thing that you would see is the app asking for location permission. Geofencing lives within windows.devices.geolocation and requires location permission, same as the other geolocation APIs do. So we get that right off the bat. Now, this app lets us create geofences with varying properties and simply pops a UI and audio notification when a geofence is triggered. For simplicity, since we're not moving right now, we're going to go ahead and create a geofence around our current location. So you can see in the app we have a button to set a reminder at the current location. Now, it's going to ask for a reminder message. So I'm just going to go ahead and put in a test build message. Now I'm going to set the radius of the fence to be 75 meters just to make sure that it encompasses my building enough. I'm going to leave the latitude and longitude the same, which is my current location, as well as the dwell time, and I'll leave it on the default monitored states of entered and exited. I'll go ahead and set a reminder. Let me zoom in a little bit so you can see it. Now the dwell time was 10 seconds, so I need to be in it for 10 seconds before it triggers. And now you've seen the geofence trigger. So let's walk through how this works in the code. So first and foremost, our app must have the location capability declared, and we've done so through the Visual Studio App Manifest Designer tool. So let's go ahead and look in the App Manifest Designer, and you can see under capabilities that we have location checked. Now, once we have location capability, we're going to go ahead and create a geolocator object, because remember, geofencing lives within windows.devices.geolocation. And once we have that set up, we're going to go ahead and get location permission. As getting location permission for your app requires user consent, the best way to do this is just make a call for the current location. We can do that using getGeoPositionAsync. And this ensures that the UI prompt will show for the user and they can enable location before you even get started adding fences. Now, before we add any fences, we also want to make sure that we get set up to listen for geofence state change events. This will let us know when something has changed, such as somebody entering a geofence that's being monitored for the entered state. So here you can see us setting up a listener. It's as simple as this. So now let's spend a little bit of time looking at how we're adding geofences. As this is a location-based reminders app and we're utilizing the mapping functionality, we're using the Bing Maps SDK. And this makes it easy for a user to add a fence via clicking or touching on a map, as opposed to forcing them to type in something more complex like the latitude and longitude. So we have some basic code to detect where the user has clicked or touched. And assuming that is successful, we store that as a location, and when we go and hop over to the Creating Fence page, we actually send that location along with it. Now, other than location, we also require a Geofence ID, which for the Location-Based Reminders app is simply a reminder message. So you can see right here that we are capturing that message. And we also have some very basic error checking in place to tell the user that, hey, you forgot to put something in this box, so please check your input. Now, besides the reminder, we also have text boxes for the other properties, such as the radius, the dwell time, the duration, and we also have checkboxes to allow a user to specify the monitored states, such as entered and exited. Now, once we've captured that information, it's time to go ahead and create a geocircle at the correct location. So here is the basic code to create a geocircle at the position that we've gathered and using the fence radius that's been defined by the user. So depending on the properties defined by the user, we're now going to go ahead and use the correct constructor to create a fence. Here you can see an example of us creating a fence using all of the properties. So here we have the reminder message, we have the circle that we just defined, the geocircle. We are doing the entered state as well as the removed state, and then we have all the properties that the user put in the boxes, such as single use, dwell time, duration, start time. Now once we've created the fence, it's time to go add it to the Geofence monitor. And it's as simple as this, geofencemonitor.current.geofence.add, and then give it the fence that was just created. Now you'll also see that down here, we are adding the fence to another list as well. And this is more for UI purposes, just to keep the push pins and stuff up to date, so we're not going to dive into that too much here. All right, well now that we have our fence creation set up, well, what if we want to do something more advanced and read some properties out of the monitor? Well, imagine we wanted to let the user touch on a push pin and give them information about the fence. So here you can see when a user touches a fence, we read into the Geofence monitor and we ask for things such as the monitored states or the duration, and we actually display those. In addition to that, we also want to show some location information in the UI, which kind of helps with debugging and also makes it a slightly better experience. So using the geofencemonitor.current.lastKnownGeoPosition, we can just get that position information and write it to the screen. So here we're taking the latitude and longitude and accuracy and just writing it on the screen. Now let's set up our logic to handle fences getting triggered. For the Location-Based Reminders app, we're popping a simple UI message when a user enters or exits a fence, as well as playing an audio noise. Now once the listener we set up earlier notifies us of an event change, we simply read reports using the geofencemonitor.current.readReports. Now, depending on if the report is an entered event or an exited event, we're going to go ahead and call the corresponding function. So here is for entered events, we're going to be calling that. And for exited events, we're going to be calling that. So let's go take a look at the entered functions to see what actually happens. So when we get an entered notification, we jump into this function, and you can see we are playing a sound as well as doing a message to the screen that says, hey, you've entered the fence and here's the reminder message. Now at the same time, the read reports contain a lot more additional information that you could use if you want to. In this case, we wanted to take the latitude and longitude from the read report and actually display that on the screen as well for the last notification. And so you can see us doing that up here. So let's go ahead and recap what we just covered. For geofencing, you must register for the location device capability, create a geolocator object, and then get location permission from the user. Once you've done that, you need to register for geofence state changed events such that when a user enters or exits a fence or a fence is removed, that you actually get notified. You create geofences, you add them to the geofence monitor, and you can also query properties on the geofence monitor if desired. Whenever a geofence is triggered, you simply call read reports and perform whatever app functionality your app needs. All right, so let's go ahead and rerun this demo now that you know a little bit more about the geofencing APIs. So again, I'm just going to zoom in to my current location, and I'm going to set a geofence around my current location since I'm not moving. Again, I'm going to make it slightly bigger than 20 meters. I'll make it 75 meters so that we make sure that we're fully in it. And I will set the dwell time this time to 5 seconds. Let's go ahead and set it, see what happens. So you saw that the fence fired. We triggered an enter event. And now you can also see up top the last known geoposition that we're reading from the monitor that we had explained earlier, as well as the last reminder message, and that's where we're pulling out the latitude and longitude of the last geofence reminder. Now, what happens if we create a geofence that expires? What happens? Well, let's go ahead and give it a try. So we're going to create a fence over here, and we'll leave it on the regular size. We're going to change the dwell time to 5 seconds, and we're going to set the duration to 10 seconds, meaning that it's going to expire in 10 seconds. Now you can see we're over here to the right, and that new fence is over there to the left. All right, well, 10 seconds has passed. Nothing's happened. And why is that? Well, that's because we didn't set up any action on the removal monitored state. So let's go back into our code and see how we can make this work. So here in our geofence creation code, you can see that we're already looking for the removed event. And that's because we didn't even create a checkbox for that. So we just added it in when we created the fence. Now, when reading reports, when we get a removed report, we're currently not doing anything with it. So let's go ahead and take a look at what it would take to process a remove report. Well, you can see for entered and exited, all we really do is call a function, depending on which one we get. So let's go ahead and do the same thing for a removed event. I'm just going to copy paste in some code from Notepad. And there we go. Well, now we need to actually set up the function to process a remove trigger event. So down here you can see we have a function set up to process the entered trigger events as well as the exited trigger events. And all we're going to do is add in the exact same thing for removed. And what we're doing in this function is that whenever we receive a remove notification, we're going to go ahead and play a sound, do the message dialog that says the fence was removed and whatever the reminder was, as well as put the information about the last reminder up in that little UI area in our app. So now that the code's in there, let's try that again and see what happens. Let's go build the app. All right, so now we're back at the app, and let's go ahead and try to add a fence that expires again, and now see what happens. So go ahead and create a fence over here. And I could leave the size the same, dwell time the same, and let's have it expire in 11 seconds. We're going to go ahead and set that. You can see we're way over here, so we're definitely not going to enter this fence in time. And after 11 seconds pass, we get a removed event. All right, so now you know what geofencing is and how it works. What about if your app is in the background, suspended, or the system's in connected standby? Well, that's where the geofencing background task type comes into play. Windows has a background task infrastructure, which was also present in Windows 8, to enable lock screen apps to enable scenarios in these cases. In Windows 8.1, there is a brand new background task type specifically for geofencing. Within your app manifest, you're going to be declaring the background task type that your app uses. Now you can see here that we've selected timer, system event, as well as the new location task type. Alternatively, you could manually go into the manifest and add the task types yourself. Note that location is in a new namespace denoted by M2, and that indicates that it's for Windows 8.1 and not for Windows 8. And similar to the timer or audio or some of the others, the location background task type does require that the app be on the lock screen in order to function. Now, as background tasks in general are not new for Windows 8.1, I'm going to only be touching on this content briefly, and I recommend you do go attend the background task talk referenced at the end of this presentation, as well as refer to the developer content online where you can find additional information and samples. Now, using background tasks, you can customize depending on your app. So say in the case of the location-based reminders, all you want to do is pop a toast and make an audio alert. Well, you can do that using the custom background task. Now, you can also do things such as update the tile on the start screen. In addition, with background tasks, you can specify system conditions that must be met before your background task is acted on. These are things such as checking for internet connectivity or checking if the user is present. Now imagine I have an app that auto checks in and checks out for a user at a particular location. Maybe that requires internet. And so I can use the system conditions to ensure that the background task waits for this condition to be met. The steps to enable geofencing as a background task are similar as they are for something such as the timer task. Now, after registering for the new location background task type in your manifest, you're going to be creating a background task associated with that location trigger. And after registering the background task with the system, including any system conditions that you care about, such as internet available or user present, you're going to simply associate an event handler with that background task. This will get you set up for the on-complete notifications from that background task. And once a geofence for your app has been triggered, your app will receive an event from this new event handler, and at that point, your app would simply read reports and act accordingly, same as we've already shown in the location-based reminders demo. So there you have it. You've seen the new geolocation API additions in Windows 8.1, and you've learned about geofencing and seen it through the location-based reminders example app. The API set is clear and easy to use, and we can't wait to see what you come up with and add to your apps. So thank you for listening to all this content. There are a few related sessions that I recommend you check out. There's a talk specific to background tasks, as well as a talk for apps that use devices. Now beyond that, the samples and documentation for geolocation and geofencing are ready for you to use and ready for you to look at. The sample is available in multiple languages and shows geofencing both in the foreground as well as in the background using the new location background task type. So please check it out, enjoy, and thanks again.